thing given to us was four charges Q1, Q2, Q3 and Q4 of same magnitude are fixed along the axis x equal to minus 2a, minus a, plus a, plus 2a. So see here, minus 2a, minus a, plus a, plus 2a. So see, a positive charge Q is placed. See, this Q is also a positive charge placed on positive y-axis at a distance b. Four options of the see here, four options were given, and we should match them for what? For the net force. Final resultant net force is along which direction? We should mention that. Okay, this is our challenge today. Let's use this. Yeah, now watch Q1, Q2, Q3, Q4, that is Q1, Q2, Q3, Q4, everything is positive. That means, see, due to repulsive forces, the as Q1, Q is also same or of same magnitude, and also especially those both are in positive, those both are positive charges, so they will be repelled. So the force of repulsion will be in this direction. Q2 and Q also in the same way repulse. All the four charges are of same magnitude. It was given in the question clearly that Q1, Q2, Q3 are of same magnitude. So Q3 in this way and Q4 in this way. So due to positive charge repulsions, the force will be in that direction. Also, finally, the resultant net force will be in this direction. Which a question how it will happen means I already uploaded about that detailedly with even an example question. Okay, the net force will be along positive axis. So P goes to 3. Okay, now P goes to 3. That means two options are left for us. Now Q also 1, it was given R changes. See, R was given like 4, 2. So which one does R goes to? Let's check it. Q1, Q4 were positive, and Q2, Q3 were negative. That means Q1, Q4. These both two were positive, and Q3, Q2, Q3 were negative. If you observe this clearly, I already explained you about unstable equilibrium and stable equilibrium even. That was also uploaded in my channel. If you didn't watch till now, please do watch and then watch this video, or else you will not be able to understand the question. So see, Q2, Q3, these both will attract because Q2, Q3 are negative and Q is positive. See, first of all, Q1, Q4 are positive. Due to these repulsive forces, let's say Q displaces up to here. See, this up to here Q is displaced. Then because of attractive forces of Q2 and Q3, because they are negative positive attraction, negative positive charge attraction, due to that Q1 Q comes back to the same place. That means it exists here only. So it comes down. Q1, Q4 are positive, it goes up, okay. Then Q2, Q3 attracts down. So it comes along minus y-axis. So R is 4. So the correct option is A. Okay. So our correct option comes out to be A. Okay. This is the way we solve the question, and this is JEE Advanced 2014 question. Okay. Yeah. Let's go to the next question without delay. So this is our next question. Two balls of same mass and carrying equal charge are hung from a fixed support of length L. At electrostatic equilibrium, assuming that angles made by each thread is small, the separation x between the balls, that means the distance. See, I think it's better to use my notes. pretty much comfortable even. Okay, let's go through the question once again. See, two balls of same mass and carrying equal charge. Two balls of same mass and carrying equal charge are hung from a fixed support of length L. At electrostatic equilibrium, what is meant by electrostatic equilibrium? First, you should learn about that. Electrostatic equilibrium is nothing but the net force will be zero. Okay? Electrostatic equilibrium means zero net force is present in that conditions and that particular experiment or something. Assuming that angles made by each thread is small, that means angle should be neglected. Okay, theta should be sine, let's say suppose sine theta, it should be neglected, it should be treated as theta. So the separation x between, that means the distance between the two balls were asked. Yeah, let's solve this question without any delay. See, there we go. So the thread is very fine. When this thread comes right, it's, see, two balls were hung it seems. See, it makes theta. Okay. Now the distance between these two balls, let's say it has x. This was asked in the question. Okay. So first draw FBD for this big ball. This is the one, right? So downwards mg, and this is tensional force to the string, and force of repulsion, right? This is q, this is q. The force of repulsion is kq square upon r square. This was the diagram. Okay. Now we are asked to we are asked for the relation between x and l in the question. If you carefully observe, see here, the separation x is proportional to which l bar, which means the relation between x and l. Okay, proportionality relation. Yeah, now go to the question. Yes, kq square upon r square, this is tensional force. Also, if you carefully observe, t can be given because yes, now find out the components first. Let's say along x-axis it is t sin theta, and along y-axis it's t cos theta. Now let's see t cos theta. What is t sin theta is equal to kq square upon r square. T cos theta is equal to, my writing is worse, right? Please do leave it. I think it's better to use this one. My writing will be good, right? T cos theta is equal to what? Mg, right? Now if we divide them both, tan theta results as kq square upon r square mg. So here r refers to x, right? The distance between them is x, so it is x square. Tan theta is, yeah, hope you all understood. Tan theta is kq square upon x square mg. So leave it. Now we can use trigonometry. See, this t can be given as root over mg whole square. This resultant vector, right? So mg whole square plus kq square upon r square whole square. So this is not needed, but I was telling you. See, now we are having t sin theta and t cos theta even. T cancels as we are divided. When we divided, tan theta results as like this. So now watch it. Now we found out, yes, using trigonometry. Let's do it here only. See, now theta. See, this is x, right? This is x by 2, and this is, let's say, y. No, this is L, right? Because okay, right? Now if you see here, x by 2 and this is L, right? This is length L. Yeah, we can go down better. We can copy paste this. See this diagram. So this is what our diagram is. Now by trigonometry, see, let's say sin theta. What is sin theta? Opposite side upon hypotenuse, which is x by 2 by L, which is x by 2L. Now if we carefully observe, theta is neglected in the question. I already told you sin theta is nothing but tan theta, which is nothing but theta. Okay, so sin theta is nothing but tan theta. So tan theta is also x upon 2L. But if you see here, what is tan theta related as kq square upon x square mg. Okay, so by replacing this, we get x by 2L is equal to kq square upon, where is that? Yes, kq square upon x square mg. So I will correct me. So if you send x cube is equal to kq square 2l upon mg. So if we remove all this as constant and we are only required to find proportionality relation between x and l, so x cube is directly proportional to l, which means x is directly proportional to l power 1 by 3. So this is the correct answer and let's go through that. So our correct answer is L power 1 by 3. Okay. That's all. That's all about the question. Also, there is other question, actually the same. Yeah, the question is two identical charge pairs suspended from a common point by two mass systems of a length L, blah 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 was given. But it was actually the same question. This is also a JEE main question. Apart, because of the mutual repulsion, the charge begins to leak from both the spheres at a constant rate. See, whenever you are finding a word rate in the question, see, whenever you are finding the question rate, okay, whenever you are finding the question the word rate in the question, that means it's nothing but differentiation. So dq by dt, constant rate of what? Charge. What is charge? Dq, which is dq upon dt is constant. It was given constant rate. So also as a result, charges approach each other with the velocity v. That means those charges will approach each other. See, first of all, two identical charge pairs suspended from a common point by two mass systems of length L are initially at a distance d. D can be neglected because L is the length of string is L. Apart because of their mutual repulsion. That means those both are identical charges. We already know that identical charges always repel each other. Due to that mutual repulsion, they go at a distance from they go away each other from each other at a distance d, of a distance d. Now the charge begins to leak from both the spheres at a constant rate. As a result, so whenever charge leaks, automatically those mutual repulsion will be decreased and those will be approaching each other. So as a result, charge approaches each other with the velocity v. Then as a function of distance x between them, then v is approaching as a function of x between them. Then as uh, actually it is the proportionality relation between v and x whenever charge leaks and those both charges were approaching each other with velocity v. Then the proportional proportionality relation between velocity v and distance x is asked here. So if we carefully observe, let's the question is as same as the question asked before. So see, so see here in this question we got a relation, right? See, x, yes, we can go on from here. So yeah, see, x by 2l is nothing but kq square upon x square 2mg. So x cube is equal to kq square upon 2 kq square 2l upon mg. So we are required to prove between x and l proportionality relation. That was proved in the before question. But now the question is to whenever the charge leaks, those charges will approach each other. So that on approaching each other, the relation between velocity, the proportionality relation between velocity and distance x is asked. So now see, x cube x cube is directly proportional to q square. That means x is directly proportional to q power 2 by 3, right? So this is the one we found out. And here we were given that in the question the charge constant rate, charge is at constant rate, which means dq upon dt is constant. So on differentiating this one, see dx by dt is directly proportional to dq by, see whenever we differentiate this we will get n into q something, see if this is not the differentiating thing then this power 2 by 3 minus 1 and also dq by dt. As we are differentiating dq, we already know chain rule, which is the basics of our childhood. See now that is about calculus I am talking in the first year starting. So dx upon dt is directly proportional to, see this is all, I'm sorry, yeah, this is constant, also given that constant rate, that means this rate was also constant, that means this is also a constant. So now dx upon on dt is directly dx upon dt, what is displacement, definition of distance, v, right? So v is directly proportional to q power 2 by 3 minus 1, which is q power minus 1 by 3. Okay, so v is directly proportional to q power minus 1 by 3. Okay, but in the question we were given, asked it to find out the relation between v and x. Okay, yeah, see here we already found that x is directly proportional to q power 2 by 3. That means, see, q power 2 by 3, that means from here can we say that q is directly proportional to x power 3 by 2? So q is directly proportional to x power 3 by 2. That means x power 3 by 2 power minus 1 by 2. This 3 gets out to be cancelled. So v is directly proportional to x power minus 1 by 2. So this is our answer. So our correct answer is v is directly proportional to x power minus 1 by 2, which is t. Okay, this is how we solve this question. Okay, now I'm going to complete other question and end this session till now here. Okay, this is my today's approach. Okay, so this is from Monsieur, I think Irodo already proved this equation. So this is what we proved before. See here we are given the same question and the answer was given as v is equal to, velocity is equal to a by root x, which means where a is constant. This is Irodo. So from this we can say that v is equal to a by root x, then v is directly proportional to 1 by x power 1 by 2. That means v is directly proportional to x power minus 1 by 2, which just now we proved. Okay, this is what we are doing. Are you getting fun? And come on, we can do it. I hope everyone is getting enthusiastic by this. Okay, let's go to the next question. Yeah, our next question was given that two cupid balls carrying equal charges are suspended from a common point. This is all same for any question. The strings of equal length, those are equal length. Now the equilibrium separation between them is r. Okay, the distance between these two charges is r. Now the strings are rapidly clamped at half the height. That means without changing anything, they were clamped at half the height. The equilibrium separation between the balls now becomes no r. The r dash. Let's say this as, let's name this r dash. So we should find out this r dash. So for that we should find the relation between r and y, right? We should find out the relation between r and y. So let's find out. Come on. Let's go to our notes. I have pretty good notes. Yeah. Mm. See, if we in the question, the difference between the before two questions and this question was, yeah, the difference between before the questions and this question was nothing but here theta is not at all neglected, but in the before two questions, preceding two questions, theta is been neglected, which we saw and we used it pretty much easily. But here theta is not at all neglected, so we are gonna do it. Come on, you will be enjoying the sum if I now tell you. You think how for this? See, there is a plan. Already here diagram was given, right? So I was not drawing this diagram. Okay. So that's fine. That was also right. That's fine. So who was your running? Two balls were hung in this manner, and the distance between them is given as r, and the height is nothing but y. Now we are asked to find out if the same clamp it is see, this is of distance y at y by 2. At y by 2, let's say, suppose from here, so these two strings were brought up to here, and now let's say this is r dash. So we should find out this r dash and y is relation. Okay, so for this first, see, this is theta. So if we draw this also becomes theta, right? So this is r by 2, so this becomes y. Now what is tan theta here? Tan theta is nothing but, here tan data comes out to be r by 2 upon y, because I'll tell you now. See here r by 2, this can be treated as this one, right? See on the top, I'll write it with pink one. See, this is also r by 2 and this is y, so this is also y, right? So let's treat this triangle. Here theta is equal to opposite side means this one, which is r by 2, and adjacent side is y. Already I told you. So like this, tan theta comes out to be r upon 2y. Okay, now we found out tan theta here. Also by FBD, like I'll show you. Just so this resulted in r by 2y. Okay, keep it aside. Let's go down, and if you did draw this diagram, see this diagram, uh, FPD for anything, let's say here, see, this is tension, right? I'm writing FT, and this is mg, and this is repulsive force, which is kq square upon r square. So here tan theta results in kq square upon r square, that's right, kq square upon r square mg. Okay, now we can relate these two. That implies r by 2y equal to kq square upon r square mg, which thereby we can say that r cube is equal to kq square 2y upon mg. So y is directly proportional to r cube, but here y by 2 we are required to find out for y by 2. That means y by 2 is directly proportional to r dash cube, right? So r dash, here we suppose that as r dash. So whenever we treat like this, here what is y directly proportional r cube? So r dash cube is directly proportional to r cube upon 2. So if we see, this stuff. Okay. Now if we apply cube root on both sides, r dash sorry guys, is directly proportional to r cube, comes out to be r, and 2 power 1 by 3, which results you in r dash is directly proportional to r upon cube root 2. So this is our answer and the last question for today. Thank you guys for watching. I hope you understood everything with it clearly. Okay, signing off with myself.